Loud sound waves can reflect off large surfaces to create echoes. For example, we can create echoes by reflecting a sound off a large building. Though we could also use cliffs, mountains, cave walls, and other large surfaces. What exactly is an echo, though? Well, imagine we projected a sound towards the building. This forms a sound wave that carries the energy of the sound through the air. When the wave reaches the wall, it will reflect off it. This means that the wave stays in the air rather than transmit or be absorbed by the building. It continues moving by travelling away from the wall with its speed, wavelength and frequency not changing, though its amplitude might decrease. If this reflected wave reaches us, then we'll hear the sound we originally projected. The reflected wave is an echo. In your exam, you could be asked to recall what a reflected sound wave is known as, which can easily trip students up. Knowing about echoes is also useful for something else you could be asked to do in an exam. Echoes are used for some methods of measuring the speed of sound. So in your exam, you could be asked to describe a method of measuring the speed of sound. We'll go through a simple method involving echoes here, but there are other methods you can give which don't involve these. We'll start as we did in the example we just looked at, with us ready to send a sound wave towards a large building. In step 1, measure the distance to the building. So we want to stand at a point where we're not too far that we won't hear the echo, but not too close so that the reflected sound wave reaches us too quickly. A distance of around 100 metres would work reasonably well. We should also make sure that this distance is how far away we are and whatever's projecting the sound is. In step 2, start a stopwatch as you project a sound towards the building. So we could be yelling in the direction of the building or using an air horn or a speaker if we want to try and get a louder noise. Either way, we need to send a sound wave towards the building and start a stopwatch as we do so. In step 3, stop the stopwatch as soon as you hear the echo from the building. The sound wave reflects off the building and comes back towards us. As soon as we hear the echo, we should hit stop on the stopwatch. If we're 100 metres away from the building, then we might expect to measure a time of around 0.6 seconds. This is quite a short time, so you could instead play a new sound when you hear the echo. Then repeat this 10 times and find the average time for a single echo. Doing the measurement this way can be more accurate than trying to react to just one echo. For now, we'll just work with the 0.6 seconds we measured from a single echo. So in step 4, halve this time to determine how long it took the sound to reach the building. Remember that our sound wave first travelled from us to the building, then from the building back to us. Since it travelled at the same speed both ways, we can halve our measured time to determine how long it took to travel the 100 metres to the building. This would be 0.3 seconds. Then in step 5, use the time and distance to calculate the wave speed. Remember that we can calculate a speed by dividing the distance travelled by the time taken. In this case, we've measured that it takes a sound wave 0.3 seconds to travel 100 metres. So the speed of the sound wave is 100 divided by 0.3, which is approximately 330 metres per second. Now, while you don't necessarily have to describe this method in an exam, you could be given the data from a similar experiment and have to do this calculation. Or you could suggest ways of making the measurement more accurate, such as by measuring a series of echoes instead of just one.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy to follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!